Number 38. Find the currents flowing in the circuit in figure 21.52. Explicitly show how you follow the steps in the problem-solving strategies. Yeah, no, I don't think we're going to follow those steps. Instead, I think we're going to do it. Now, before we get started, what I want to do is you definitely have to watch over, to get these formulas, watch over number 35, 36, and 37. All right, because here's the formulas that come out of those problems, and these are necessary to perform this problem. So instead of literally repeating myself just verbatim again, because I would have to do that, and this video would be, an hour and 90 minutes and 4,200 seconds. Instead, what I'm going to do is just, get right down to business in calculating it, and please see those videos for an understanding of where these formulas have now come from. Okay? So we can now solve our problem by just using these three formulas. And that was kind of the point of the prior three problems. So now what I realize is, first thing is, let's clean this up. All right, let's just clean up these formulas. Let's combine some like terms, and then we'll take it from there. Okay? So I'm going to work with this equation from number 36. And by the way, your final answer to number 36 could have been a simplified answer as well. It doesn't really matter. They just wanted you to apply the loop rule. So we realize when we combine these terms here, that's going to be A30. Okay? And then minus now, all in parentheses. Let's combine all the like terms. So I'm going to highlight them for you, okay? So here's 5i1, 0.1i1, and here's 20i1. So when we combine those, it's simply going to be 25.1i1. All right, great. Now, let's take a look at the next like terms in there. I guess we're going to have 0.2i3, 0.05i3, and 78i3. So when we combine those all together, it's going to be 78.25 I3. And then there's another term in there that isn't really combined with anything. It's just 36. Okay, plus then a 36. And that's all equal to 0. So now what we're going to do is we're going to solve this. Well, let's still simplify it a little more. Okay, so we realize we can distribute the negative now to each of those terms inside. So it basically becomes now 30 minus 25.1 I1 minus 78.25 I3 minus 36 is equal to 0. You still have like terms here, so combine them, and we're going to get a negative 6, right? So this will be now a negative 25.1 I1 minus a 78.25 I3 minus a 6 equals 0. Now, if every term has a negative, you can basically factor it out, right, and divide out a negative 1 if you wanted, or just simply move all of these things to the other side. No matter what you do, we can just simplify this by just getting rid of now those negative signs, because it basically would all become positive. All right, so that just might be easier here. Actually, I don't know if it would be technically easier. Yeah, why don't we just leave it, because I see we're going to have to do something anyway. So what I want to do now, so let's leave it here, sorry. And what I now need to identify. All right, so let's leave this alone, okay? Now what I'm going to do is I'm going to simplify my equation from number 37. Okay, so let's do that next. So let's simplify that guy, all right? Or girl, doesn't matter. So we got combining some like terms in here. We're going to realize that we have all I1s in here, right? So we're going to combine these I1s, 20I1, 0.1I1, 5I1. So inside of that parenthesis will now be 48. It's a weird 4, but 48 plus 25.1 I1 minus then, combine some like terms in here, so it looks like we have some like terms of 0.5 I2 and 40 I2. So that's going to simply be 40.5 I2, and then plus the 24, and that's all equal to 0. All right, so now let me just move this down here a little bit. And distribute now that negative sign to each term there, and we're going to get then 48 plus 25.1 I1 minus 40.5 I2 minus 24 is equal to the 0. Combine now these like terms, all right? And when we do that, we get a positive then 24, right? So 24 plus then 25, 25.1 I1 minus then a 40.5 I2 is then going to equal 0. Okay? So now, to solve the problem, there could be several ways to do this, by the way. You might even notice that these two formulas have common I1 terms and they're opposite. right inside. So you can add these both together if you wanted. Then you'll have a new term, though, with I2 and I3 in it. It might not help out directly, but if you needed an equation that related I2 and I3, you could find it. I'm not going to do that for this problem, all right? What I'm going to do now is I'm just going to take a step back. I realize I got these two formulas, and I realize I have this formula over here on the top right. So what I notice here is that there are three variables in my three equations here, right? I got I3, I2, and I1, and then I have I1 and I2, I1 and I3. So whenever you get yourself down to a point like this, the best way to do this, okay, is going to be to solve this equation for I2. Then you're going to solve this equation for I3. Now what that allows you to do, if you think about it, if you solve this equation for I2, you'll get I2 equals some type of set of numbers, with your I1 on the other side, right? And then if you solve this equation for I3, you'll get I3 equals some subset of numbers, with an I1 on the other side. Now notice that if this side has an I1 only in it, and this side only has an I1 in it, then what I can do is I can simply now take I2, plug it in for I2 in this formula, then take my I3 value and plug it into I3 in that formula. In other words, what I'm saying is take this, plug it in for I2 because that's what it is equal to. Take this and plug it in for I3 because that's what it is equal to. And then what you'll realize is you will have now one equation with only one unknown, I1, I1, and I1, and that's solvable. Okay, so that's going to be the strategy. So let's back out of this a little bit now, and let's see what we can do. So we're going to, again, solve those two equations for I2 and then I3. So let's get to work. So let's solve the first equation. And by the way, there's more than one way to solve the problem. So however you might see a different way to do it, and that's great, as long as we get to the right answer. Okay, so let's solve this for I2. So let me just actually, since it's already here, let's just move it on up. And how are we going to do that? Let's get these terms on over to the right-hand side. So we're going to subtract 24. You can subtract this whole thing, if you wanted, 25.1 I1. So that whole thing would cancel, okay? And you're going to have to bring this on over to this side, right, as a subtraction. So it's basically going to look like then negative 40.5 I2 is equal to then this whole thing on the right-hand side, negative 24 plus 25.1 I1. Now notice that there's two negatives on the, so you can just get rid of them if you wanted, or just simply divide out now negative 40.5 from both sides. Careful, you got to leave that parenthesis in there. I realize I did not, and that means it's just negative 24. You got to have the parenthesis there. Then divided by negative 40.5. So now here we're going to get I2 is equal to, the negative signs will cancel, and don't simplify this yet, okay? Just leave it as 24 plus 25.1 I1 all over 40.5. Okay, this is what I2 is equal to. All right, so that's something we're going to keep on the side. All right, now do the same thing for the second equation there. So we're going to bring that up to the top. So let's take this and we'll go whoop. And now solve this for I3. Okay, so that means I have to add my 25.1 I1 to both sides, right? So here's the equal sign. So I'm going to add it then to 25.1 I1. And then I have to get rid of the 6. So I'm going to add the 6. Right, that cancels, and then I have to add my 6 to the other side. So I'm going to get something that looks like this now. Negative 78.25 I3 is then going to be equal to, it doesn't matter how you organize it now, 6 plus 25.1 I1. Okay, and now I got to get rid of this negative, right, 78. So simply just now divide that on out. All right, so divided by negative 78.25. And here we'll go negative 78.25. All right, and now let's write down what we got. So this is going to be now I3 is equal to, I think I'm going to bring the negative sign out, and I'm just going to bring it up. It doesn't matter. You can leave it there. I don't think it really matters. It doesn't matter mathematically. I'm just thinking about what'll be easier later on. Let's just bring that, let's leave it. Screw it. Let's leave it. So let's just rewrite it. 6 plus 25.1 I1 all over then negative 78.25. So now notice what we got. Okay, we got these two equations, and this is I3, right? I3 is equal to all this, so what I'm going to do is I'm going to take it and plug it in here. And then what I'm going to do is I'm going to take this, okay, and then plug it in for I2 in this equation, okay? So let's see what we're going to do. Well, that's what we are going to do. Now let's see how we're going to do it. Okay, so I'm just taking this formula here, right? So we got I3 plus I2, I3 equals, I2 plus I1, and that's the equation from number 35. And for I3, I'm going to plug in now 6 plus 25.1 I1 all over then negative 78.25. And that's then going to be equal to your I2 now, which is 24 plus 25.1 I1 all over 40.5, and then plus now your I1. All right. So let's get rid of this. So everything looks fine. And now all we got to do, we got one equation with one unknown that is solvable. Okay. And actually maybe what we'll remember that this is equal to I3 and this is equal to I2 because we might need it later on. All right. So, okay. So now we just have to do a little math. And I think what I'm going to do is I think at this point now I'll start finding the values. So what I think might be best at this point is to take the denominator and divide it into each of the numerator values. Okay, divide it into each of the numerator values. I'm going to round when I write it down, but when we do the calculations, try to use the exact values, all right? So 6 divided by the negative 78.25, that works out to be a negative 0.0767, okay? Minus then, because now you're going to divide those two, it's going to be a positive 25.1 divided then by a negative 78.25. And this is now a negative 0.321. All right, I1, don't forget that. And that's now going to be equal to, we got to do the same thing on this side. So take your 24 and divide it then by your 40.5. So that works out to be about 593. Oh man, hopefully I don't make a silly mistake because there's so many numbers. And then, sure, 25.1 divided by then 40.5. And this now will work out to be 0.6, I guess 620 I1, right? And then simply just plus I1. All right, so that's just now going to be plus I1. Okay, so now what we'll start to do is we'll start to combine some like terms, all right? And start maybe, so I'll just combine these two. We'll take it step by step. So this is the negative 0. Actually, you know what? Let's just do it all at once, right? So what I'm going to do, I'm going to collect all my i's because I already have 2 over here, so I'm just going to bring that one over. So I'm going to add this 0.321 I1 to both sides. So that cancels, right? And then what I'm going to do is I'm going to move this number away. So I'm going to subtract it, 0.593 minus 0.593. And now I realize that cancels. So now what I'm going to do is I'm going to add up all these in the calculator. Okay, this number, there's just a 1 in front of there, remember? Just a 1. And this number, okay, I'm going to add up the exact values. So if your value differs slightly than mine, it might be because you're using the rounded numbers on the page. I'm using the exact numbers from the memory in the calculator. Okay? All right. So then, so let's see. And we're going to add 1 to that. So I get a value here. Then I'm going to round again is about 1.94. Okay, I1. And then now I got to combine those two, right? Exact values. So they're just going to come out to be overall negative, so you can just add them up. So the 5.9, okay. And then add it to this 0.07 value. Where's that guy? And that's a negative. So just give me 1 second. So I just have to actually subtract it because it's going to come out to be negative. No big deal. Okay. And here we're going to get overall negative. Overall negative 0.670 or so, right, if I round. Now all you have to do is just divide it out. Just divide out the 1.94 over the 1.94. And the current here now, I1, is going to be just that division, all right? So so the answer is negative 0.345 amps. Now the current is allowed to be negative, and the negative doesn't mean like, you know, either the current flows or it doesn't flow, right? Theoretically, you know, the negative sign just means direction, that's it. So all it means is that, according to the problem, they said that I1 should be flowing this way. But guess what? It's not. It's going this way. No big deal. That's all the negative sign means, okay? It's just flowing in the opposite direction of what's stated. But that's the interesting thing, that it doesn't matter how you actually, if you stated this right or wrong, as you're calculating, what matters is when you get your answer for the current to be able to interpret what that means, the negative sign. All it means is that if the current you chose is going clockwise, the real current in reality is going counterclockwise for that part. That's all it means, okay? Now, okay, so now we're good here. So we got I1. Now what we can do is, actually, let me just erase this part. Okay, so we got I1. All right. So I'll write it on the top right. So I1 was equal to negative 0.345 amps according to the current, you know, according to the direction of the current we stated. All right. Now what we can do is I can find both I3 and I2 now, simply. The reason being is because, remember, these formulas we've solved already. I3 was equal to this thing, right? And then the I2, all right, was equal to this thing. So if I want to solve for I3 then, that would be equal to 6 plus 25.1 times my I1 value, negative 0.345, all over then negative 78.25. All right, so what's I3? Well, take out the handy-dandy calculator, right? So it's going to be 6. It's going to be 6 plus now 25.1 times a negative, I'm going to use the exact value from the calculator, all right, and then divide that whole thing by now negative 78.25. Notice how it works out to be positive, all right? So it's now 0.0340, I guess, considering the rounding, okay? So that is now the current. And all that tells me is that the positive answer just tells me simply that we were right, meaning, or the stated current is flowing in the right direction here. So on the bottom part, it is flowing this way, okay? It is moving in the right direction, okay? That's all that means. And okay, great. So now here we go. So now we got that value. So let's just write that on the top. I3 is going to be equal to 0.0340 amps. All right, beautiful. And now last but not least, I'm going to now there's a couple of ways you can solve I2, obviously. I'm just going to use this method. So I2 is equal to, remember this whole thing. So it's just 24 plus now 25.1 times our I1, which was negative 0.345. Let me use the exact value when I calculate it, divided by now 40.5. And I2 now will be, so 24 plus now 25.1 times the negative 0.344892, right, all that stuff. And then divide that now by 40.5. And again, it works out to be a positive answer. What do we got? 0.379. Sorry. 0.379. Okay. And that's I2. All right. So I'll just put that answer up at the top. And we got now I2 is equal to 0.379 amps. And those are all the currents now. All right, that's how you do it. It's not that bad. A long problem, right? Because also we had to apply loop rule, right? We had to apply the 2 loop rules here, loop rule 1, loop rule 2, and then we had to use junction rule to figure this all out. So it was a very long problem. But hopefully now that makes sense. So in reality, just considering the current, so we have a current flowing in here, okay? In reality, I2 is really flowing this way because I2 was positive, so the stated current is in the correct direction. I3 was also positive, so therefore we know that that is flowing this way in the circuit. Okay, so that's great. So I3 is really flowing that way. And I1 now is just opposite to what was stated. All that means is that I1 now is going to be going, in reality, this way. Okay, so that's I1. So now you know the correct directions of all the currents, all right? And what we realize is it still all makes sense. At the junction then here at A, we have I3 coming in, we have I1 also coming in, but then we have I2 leaving. So that makes sense. Remember, we can't have them all coming into a junction. That would not make sense. If I1 was coming in, I3 was coming in, and I2 was coming in, something is wrong, okay? So we got essentially 2 inflows into the junction I1 and I3, and we have 1 outflow. That should hopefully make sense. Same thing here if we analyze point E. We have 1 inflow into point E, that is I2, and then we have 2 outflows, I1 and I3. All right? So notice how, do not, when you approach a problem like this, don't get too concerned about the direction of the current. In other words, what I mean by that is, don't sit there and think, oh, is the current really flowing this way? Or is it flowing the opposite way? How do I figure that out ahead of time? Guess what? You don't have to, and you're not going to. All you're going to do is you're going to choose and make a guess as to some direction of the currents. Just make sure it makes sense by don't have 3 currents flowing into a junction. That's a no-no, all right? Because that just won't name, that just doesn't happen. So make sure that you got, some flowing in and some flowing out, all right? And then after you do that, when you make all your calculations, the signs will tell you if you were right or wrong in your prediction. But that's okay, because now you'll know if you were right or wrong, and if you know you were wrong, then you know how to be right. Always end on a philosophical note. Guys, thank you very much for tuning in. I appreciate it. I hope this video helped. And if this video helped, please help us out by subscribing. I appreciate it very much. Take care.